So I'm Jeng. I will take over the sessions, the chairing of this session. So I would like to invite the next speaker. The next speaker is Jeng Chow from TCOMS, and he will be talking on the numerical predictions of wind wave in Singapore region. Okay, so Chow Jeng completed his PhD in mechanical engineering from Nanyang Technology University in 2016 while working with DHI Water and Environment under the EDB IPP program. So let's listen to Dr. Chow's talk. Thank you.
Thanks a lot, Ziyong. Hi everyone. Very good morning to everyone attending the conference, either physically or virtually. First of all, a huge thanks to the conference organizers for the opportunity to share some of our developments at the Technology Center for Offshore and Marine Singapore, TCOMS. My name is Jeng, one of the scientists working under the CHUA Capability Thrust. So CHUA stands for Center of Excellence for Autonomous and Remotely Operated Vessels. Okay, so currently, vessels rely on the experience and expert knowledge of mariners, as well as the vessel traffic services operators to navigate the busy waters around Singapore. And in some of these areas, we could experience regions with strong currents and waves that affects the vessel's maneuverability. Thus, an accurate forecasting of the vessel's operating hydrodynamic environment is very important, firstly, in enhancing the predictability of the vessel's responses, which can be harnessed for autonomous vessel navigation and control. Secondly, advanced data sharing and the visualization platform can provide dissemination of accurate mid-ocean information, so namely waves, currents, and wind, to the marine stakeholders. So by incorporating the sea state forecast into navigation and control systems, the performance of maritime autonomous surface ships, MTEC, and other smart maritime solutions can be further enhanced. Lastly, in prediction of the hydrodynamic environment can also be used to improve the coordination of multi-vessel interactions at the VTS level, given that the maneuverability of each vessel will be affected by the surrounding environmental forces. So it is within COPS, one of our key focuses is to develop a digital twin of the mid-ocean environment. Okay, when we talk about mid-ocean environments, it can include variables such as currents, waves, and even the wind. So today we will look more into the phase average spectral waves modeling of wind waves in the region. And in this approach, we resolve the growth, decay, and transformation of wind waves and swells in offshore and coastal areas. And in this approach, it is based on the conservation of the wave action density over the region. So some of the outputs of the model can include the significant wave height, peak wave periods, mean wave directions, and the standard deviation. So on the right, we can see a picture. Generally, this information of the hindcast can readily be downloaded from global data such as ICMWF. However, in this data, the resolution can be in the order of about 25 kilometers or even more for the forecast at about 50 kilometers. So in our model, we have, in our spectral wave model, we have used a flexible mesh approach. Generally, here we see the computational grid we have used for the simulation. For hydrodynamic numerical studies, normally there's a choice between quadrangular and triangular elements, and this is dependent on whether the flow is unidirectional or directional. But in this case, since we are looking for waves, it is not as important. But since we are using the same mesh for coupled studies eventually, so we have used this. So the focus in this, we will be looking at the resolution that we have in the Singapore Straits. In the ECMWF data, the resolution could be just one cell or maybe even less around the Singapore Straits. Right now, we can go as small as about 100 meters in the regions that matters most. Okay, next we look at the forcing data. So here we start with the hindcast study. We obtain the wind and wave data from ECMWF ERA5. The wind will be applied all over every cell over the domain, and the wave data are applied through the significant wave height, peak wave periods, and such. Alternatively, they can be applied using the wave spectral energy. Okay, here we see an animation of the results. So I would like to focus on the region that can be shown at the bottom. That is the domain of our study. In the larger domain, these are the contours are showing the significant wave height of the whole region, but these are not within the model. The model only shows over here. So what we have done is we obtained the wave and wind data over the region and applied it into a smaller region. Okay, just now we didn't zoom in. So right now we are looking at the zoom in animation of the Singapore Straits. So right now we can actually see some of the significant wave height from the contours that we are experiencing. And we can see that the landmass of Batam and Bintan is actually experiencing the waves of about 50 over meters, whereas it's only about 15 to 20 cm, 15 to 20 cm in the Singapore Straits. Okay, I have more validation data, but those will be shown in the full paper. So right now, I'll just show a few animation slides. So right now, we are looking at, in the first column, we have what we have done in the numerical spectral wave simulation. And in the middle column, it is the original ERA5 data that has been interpolated over the whole domain. So take note that the resolution was very coarse, so we did some interpolation onto the same flexible mesh we have. And on the last column, what we are seeing is the subtracted difference. We are expecting everything to be white if there is no difference between the results. So the first row shows the wind sea waves, second row the swell, and the last row the combine. So due to the coarseness of the resolution of the ERA5 data, we can see that there's actually quite a significant difference, especially in regions where there is land masses. Because of the coarseness, it does not have any data in that region. So this might cause some higher over predictions that is actually not true, because what we need to focus on are on the areas that is away from the landmass for the validations. Okay, in the next stage, we will be looking at extending this hindcast. Well, everything works for hindcast. The challenge in setting up a forecasting platform in the next stage will be generally because forecast data are at a resolution of even coarser than the hindcast data that we have. So we would like to extend the physics extend the domain to actually take into account more physics. Because as we know, the smaller the model, the more determined by the boundary conditions that we apply. Whereas if we have an extended model, we can actually let the numerical model resolve what's happening within the region. So we also expect more challenges in parameter tuning as we move towards the forecasting stage. So eventually in the forecasting platform, we will be setting up the wind data from NOAA, apply it to a regional scale wind wave model like WaveWatch 3, and then transfer this data onto our smaller spectral wave model, which we will accomplish it with SWAN. So there it shows the flowchart of the data. Everything that's published eventually will be in the red box. Things such as significant wave heights, peak wave period, mean wave directions and the standard deviation. Okay, so this is my concluding slide. With all the data that we either obtain it numerically, or some of my colleagues are working on data-driven predictions of the same, for example, significant wave heights, we would want to develop eventually a visualization platform to efficiently disseminate this information to marine stakeholders. So things such as wind, we don't generally model the winds, but we can obtain it from ECMWF and then publish it onto the same platform. Currents, we do some modeling of that. Waves. And eventually, that's just stage one, is to being able to publish all this onto a live access server. So in stage one, we will be able to see the pictures, obtain the raw data from a browser, and maybe even overlay it over Google Maps. However, what's exciting in the next stage will be, because the visualization platform is developed using the Threads server, we can easily, with the right credentials, just obtain this data and allow our collaborators to set up their own custom navigation and control system based on this data. And with the ultimate aim to enhance mass performance and other smart maritime solutions. Okay, and with that, I end my presentation and I'll be open for the next questions.
Thank you, Jeng. Amanda, is there any questions from the floor? Probably I have one question. So, did you compare your results with any data collected from the buoy?
Right. The last part is
The buoy, the wave buoy, or wave sensors?
No. Okay, as of now, we did the validations based on the ERA data only. So of course, when we obtain more wave observation, that is actually our ultimate aim. And even when we shift onto the forecasting system, that is very important because we know that any differences, let's say 10%, let's say if we get 10% differences for hindcast, a 10% for forecast of the wind will in generally cause about 20 to 30% differences in waves. So that's actually something that we will carefully treading forward. Yeah.
So do you consider an even smaller scale, say focusing on regions surrounding the Singapore Sea?
Sorry, a smaller cell?
Smaller scale, local scale.
Local scale.
Just surrounding, I mean, using a smaller scale.
In terms of refinement in the local region,
right,
yes.
Right.
Yes.
Okay. And are these data available to the public? Is it open?
No, not all.
All right.
So
okay.
we are still in the midst of.
Yeah.
Thank you very much. Very exciting to see the presentation on that. I noticed you're focusing on wind wave, and you also mentioned a swell. And I thought excellent. I think that aspect is a completely different type of forces. How about the surf? Since you're talking about the Singapore region, is surf is part of your intention to embark on this particular part of the overarching force in the SC?
Can I confirm the question is more on the scales that are smaller than?
I'm not talking about scale. I'm talking about, you mentioned the wave, you mentioned the swell. Now my question is, how about the surf? You know the word surf? Surfing.
The wave hitting on the beach, are you saying that?
Basically,
Yeah,
the
correct.
water mass is nearer to the
coastal.
coastal.
In the models, for example, SWAN and let's say in this case, Mike 21 SW, they are included in the physics, but it's actually not part of the interest in this study. So nearer to the coastal zone, or if you are referring to right beside the ships, is that correct?
No, I'm referring to basically the
coastal region.
Okay, the definition of surf basically is nearer the coast. Okay, I'm the seafarer before. I still do keelboat sailing now. I feel that that important element is we have to understand it more comprehensively. That make maybe the research more detailed. It's excellent. I feel that there's a lot of potential in there. And myself take the opportunity to really put it in more and to demonstrate this small country can really put our skills into a very useful to the potential application.
Yeah,
user. Thank you very much.
agree. Thank you.
All right. Thank you. Thank you. Yeah, one more questions. One last one. Yeah.
It's not really a question, it's more a comment. So I'm Per Kristalund from Norwegian Embassy. I think this could be very relevant for aquaculture development, open cage systems in Singapore, especially when you do assessment of the open cages, larger floating systems and stuff like that. Are you looking at specific applications in this form? I mean, would you be able to do tailor-made predictions, wave predictions for, let's say, the aquaculture industry?
Sorry, you mentioned aquaculture? Right?
Aquaculture.
Aquaculture, yeah.
Yeah.
It's
Fish farming.
definitely, it's definitely part of the possibilities that is something that we can look towards.
Okay, maybe I can answer that as well. Yeah, it's certainly a possibility, but because this research is primarily funded by SMI for autonomous vessels, hence the output is tailored towards that. But you're right, it's the same ocean, the same seas. Yeah, we can apply to everything, including coastal engineering, addressing the shoaling and the surf effects.
Right. Thank you. Thank you, Jeng Hei.
Thank you.
Thank you.